Introduction. The subject was initiated first by English engineering Oliver Revised 1850 to 1925 from operational methods while studying some electrical engineering problem. However, Haverside's treatment was not very systematic and lacked rigor, which later on attended to and recapitulated by Bromwich and Carson. Laplace transform constitutes an important tool in solving linear ordinary and partial differential equations with constant coefficients under suitable initial and boundary conditions by first finding the general solution and then evaluating from it the arbitrary constant. Laplace transforms, when applied to any single or a system of linear ordinary differential equations, converted into mirror algebraic manipulations. In case of partial differential equations involving two independent variables, Laplace transform is applied to one of the variables, and the resulting differential equation in the second variable is then solved by the usual method of ordinary differential equations. Thereafter, inverse Laplace transform of the resulting equation gives the solution of the given PDE. Another important application of the Laplace transform is in finding the solution of mathematical model of physical problem, wherein the right hand of the differential equation involves driving force, which is either discontinuous or acts for short time.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD WALIUDDIN bin Ahmad SHUKERI. My metric number is DE 2086. Now I'm going to present my part, which is formulation for our circuit, for our project. So for our circuit, the model of our circuit, which is RLC, consists of inductor, resistor, and capacitor. So we have set for each component value, which is inductor 2H, resistor 10 ohm, capacitor 0.4 farad, and the power series 100 unit applied to the circuit for the ET. So there are 8 steps for the manual calculation. So for the step 1 is to determine the ET, which means when the 100 unit applied to the circuit, that means the time for the time is under or below x second. After x second, 0 unit applied to the circuit. So step 2 is modeling the ODE, which is VL plus VR plus VC equal to ET. And then step 3, convert step function of ET to unit step function. And step 4, substitute values of R, L, and C. And then step 5, apply Laplace transform into the R, L, and C value formula which means for the inductor, resistor, and capacitor. So for step 6, substituting the initial condition I 0 for the 0 time second. For the step 7, then we solve for the IS. And then the lastly for step 8 is taking inverse Laplace transform to get the final initial value for the RYT. So that's all from me. Thank you.
So my name is Shahrul Nizam. I'll be presenting about the manual calculation for our circuit. Here we have the question, the RLC circuit that first is in initially at rest. It has a power series of 100 units and it is applied to the circuit for 8 seconds. For this question, we have to determine the current, which is IT. Okay, so for the first step for this question, we have to determine the ET. We have to get the power series, and then we will get the T which is applied for the circuit, which is 8 seconds. Then for the second step, we have to model the ODE. We have to take the capacitor, the inductor, and also the resistance. Okay, after we get the L, the R, and the C, then we convert the step function of the ET into step unit function. After that, for step 4, we substitute the values of the inductor, resistor and the capacitor, and then we will have to apply the Laplace transformation. After that, we'll substitute the initial condition, which is ZO equals to 0, and we'll get the equation as SIS plus 1 over IS and plus 2.5 IS over S equals to 100 over S, and then minus 100 equals to exponent negative at power of negative at S over S. Then for step 7, we have to solve for the IS. We'll have to solve for the IS, and then we'll get the answer as IS equals to 100 over S plus 5 power 5 power of 2 minus 22.5, then minus 100 exponent negative power of negative at S over S plus 5 square root minus 22.5. Then for the last step, for the last step, we'll be using the inverse Laplace transform, so that we'll get the final calculation for IT, and we'll get the answer of IT, which is shown in the picture. Yeah, and that's all for manual calculation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD AIZIL FIKRI RASLAN with the metric number of DE 2041. Okay, today I want to present about our circuit, RLC circuit, which is we set the value of VL, VR and VC, which is the value of L 2 Henry, the value of resistor is 10 ohm, and last but not least, the value of capacitor is 0.5. So before that, the simulation that we use is Maple simulation. Then we just write the value of the formula of the circuit, which is L di over dt plus R multiplied by I plus 1 over C because it's capacitor, and IT dt equal to 100 minus 100 heavy side in the bracket T minus E. So from this formula, we get the value of this result. And then next, for the step number 5 from the simulation, di over dt plus 10I plus 1 over 0.4 I tau d tau equal to heavy side 100 equal to 100 in the bracket T minus 8, and we get this solution, which is di over dt plus 10I plus 2.5 in the bracket the I tau and d tau equal to heavy side 100 minus 100 T plus 800. And next for the number 7 calculation, which is SIS minus I bracket 0 plus 10 IS plus 2.5 IS over S equal to 100 over S minus 100 e to the power of negative 8S over S, and we get the result, which is SIS minus I0 plus 10I plus 2.5I per S equal to 100 per S minus 100 exponent to the power of E to the power of negative 8S per S. And for the number 7, we get the value of from the previous formula. We put the IS in the bracket S squared plus 10S plus 2.5 over S equal to 100 minus 100 exponent to the power of negative 8S over S, and we get the value is IS squared plus 10S plus 2.5 per S equal to 100 minus 100 exponent to the power of negative 8S per S. And last but not least, we write the formula of IT equal to 100 over 3 n square root 10 over 2 exponential to the power of negative 5t sine in the bracket 3 square root 10t over 2 minus 100 over 3 square root 10 over 2 exponential to the power of negative 5 t minus x sine in the bracket 3 square root 10 over 2 and then multiply by t minus x heavy side t minus x, and we get the value which is it equal to 20 square root 10 exponential to the power of negative 5t sine in the bracket 3 square root 10 over 2t equal divide by 3 minus 20 square root 10 exponential to the power of negative 5t plus 40 sine in the bracket 3 square root 10 over 2 heavy side t minus x over 3. So this formula and the answer is actual same from the manual calculation. So that's all from me, Muhammad AIZIL FIKRI. Thank you.
Hello, for discussion based on the result that we get from the manual calculation. The result shows that all of the calculation from the manual calculations are using the basic calculation of RLC circuit. In the manual calculation, first we will determine the ET from the circuit and then the model of the ordinary differential equation. After it, we will convert the step function into step unit function. Then we will substitute the value of resistance, inductor and also capacitor. Then we will apply the Laplace transformation into the equation. For the next step, we'll substitute the initial condition to solve for IS. And lastly, we will find the IT. In that, we'll use inverse Laplace transformation. And the final value for the manual calculation will be shown here. And then from the simulation, we use mathematical tools by Maple to compare our answers from the manual calculation also with the simulation answers. The simulation by Maple software, as shown, is using the same methods as in our manual calculation. The final value from both methods are the same. And here is the proof that the final answers of our simulation and also the final answers of our manual calculation are the same. Based on the evidence shown, this shows that the manual calculation done by us has the same answers and has the same methods as the simulation that we use with using Maple software.
Summary. The main purpose of this project is to solve a problem from an electrical and electronics applications area. Summary of the project is employing the appropriate mathematical tools such as Maple. We were able to solve the problem. We obtained knowledge by applying this strategy in order to solve the problem and execute our calculations while using Maple. As a consequence, the primary goals of this project, which required us to conduct calculus calculations utilizing any appropriate mathematical tools. In addition, we did a manual calculation to verify our answers. As a result, we employ our skills of Laplace transformation to obtain the precise solution as Maple. Thanks.